Okay, so today we'll be doing an ELISA test. It's the Captia Measles IgG test that is made by Trinity Biotech. When we look on the outside of the box, we'll see the kit number, the expiration date, as well as any other little information that the kit may include. So this is our kit insert. We will upload a copy of it for you. It gives you all of the instructions, the name of the test, the procedure,
Yes.
and there's a section that will help you with calculations too.
Yes. And the quality control for your readings.
Right.
And how you calculate your results.
Excellent.
And all the other pros and cons that come to it.
It also includes its own worksheet, but we tend to use our department's worksheet.
Right. Okay, so the kit is here because you have to watch the following.
Yeah.
So the kit comes with the plates. The wells, the micro wells. Comes with the wash buffer.
Yes, wash buffer is blue.
Comes with the sample diluent.
Yes, diluent is green.
Yeah. It comes with the conjugate.
Conjugate is straw colored.
Yes. It comes with the substrate.
The substrate is in a brown container so that the light doesn't go through and destroy it.
Correct. Comes with the stop reagent.
And the stop reagent. This stop reagent is hydrogen.
Positive control, negative control, positive and the calibrator.
And the calibrator. Alright.
We allow the kit to come to room temperature. Right? And we have looked for our samples.
Okay.
Right.
So we'd have received blood and we would have spun it down in the centrifuge, pour off the serum. Alright.
So we are going to label our tubes. And as the protocol, we need a blank.
Must label everything appropriately so you don't get mixed up.
Negative, control, positive, control. And for our protocol, we do our calibrator times 2, so C1, C2.
So after labeling our tube blank, or positive control, negative control, calibrator 1 and 2, then a tube is labeled for each of our patient samples according to the order numbers that they were given on entry to the lab. Off note, students, when samples come in, they come with their forms labeled with all the patient information. It's entered onto the LIS system, which is a computer. So after that, there's no need for paper-based anything. We just keep everything electronic. The barcodes are added. We use this little gadget here to scan them in. So all the tubes with the patient's blood samples come and get scanned onto the system, and their information is uploaded from the forms that will give you all their demographics, name, etc., etc. Then we have a lovely centrifuge over here where we spin down the blood. So it comes like this. We spin it down and then we pour it off. So the serum will be at the top. I'm not sure if you can make that out. The clot will be at the bottom. We pour them into these little jars called nukes, and you can see that there's barcodes on these nukes, and it's stored there. We store it in the -20 fridge. There are a couple of fridges here, and we have several others on the outside. And then when we are ready to use it, ready to test them, we take them out, allow them to thaw. So you can see these have their barcodes as well and see them in it. Allow them to thaw, come to room temperature before we conduct the test. And this is our biosafety cabinet. We conduct all of our tests in the biosafety cabinet for safety purposes. You're hearing its fan in the background. air that goes in gets sucked in, filtered, so nothing goes into your samples. Pipettes or sharps containers are disposed of any. Usually there's another little plastic bag inside on that orange rack for any other garbage. There should be also a little container with bleach, so if there's any fluids you want to throw out, you pour it into that to decontaminate before you throwing it anywhere else, not down the sink.
So this is the worksheet, and according to the protocol that is on the insert, you must have a blank, negative control, positive control, calibrator 1 and 2, because we do them in duplicates, and then you write down the order number for each test.
Right, so each patient gets assigned an order number, so nobody knows patients' names after it gets into the lab.
Correct. And on the worksheet, you indicate the test that you're doing, measles IgG, and also the kit that you're using. So we're using the kit called Captia. It's also important to note the lot number when the kit expires, and also the accepted range for your negative result, positive result, and your samples that will come down as equivocal. That information is included in the insert. So the insert gives you what is the accepted value for your negative control. Those samples that will come up equivocal, at the range between negative and positive, and your positive. So we include it on the worksheet. Anything that is less than and equal to 9.0 would be positive, negative. Anything over 1.10, and anything between the positive and the negative is equivocal. To choose the appropriate tips, pipette. Right, and the instruction says 200 microliter of the sample diluent. So we're going to set the pipette to 200. This is a 1 liter, 1 microliter. So we're setting it to 200 microliter. Alright, and the tip, appropriate tip, we're going to dispense 200 samples.
Okay, so we're going to vortex.
This is 100 microliter, that what we want, 10 microliters of the sample. The appropriate tip. Control source. We're taking up 10 microliters of the we are going to vortex.
To mix the diluent with the sample. Alright, vortexing again.
I think them ready? On the select the wells.
Right. Each plate has micro wells that are movable that can fit into the section of the plate that you'll be using for your test. It has the alphabetical system along the one side and a numerical system across the top, allow you to know which spot you're putting which sample in. So using the same alphanumerical system on our plates, we will know which spot to exactly put our sample or blank or controls in to match our worksheet. After we've checked our work list, we can now take up 100 microliters of our previously mixed serum diluent along with our sample or our controls in each specific tube and apply it to the wells that they were assigned according to our worksheet, ensuring that we follow the same order, that there's no mixing up of samples and no cross-contamination of any of our samples. So now we're at the point after incubation. We are going to now remove the fluid in each well. Quick flick of the wrist. Knock it out a couple of times. Make sure no air bubbles or any fluid remains. Make sure it's empty. Let's take a look. Alright, no air bubbles. Then our wash buffer, which has been diluted before. We use our multi-dispenser pipette to put 250 microliters into each well. Alright. Rest it down. We're going to reuse it. Flick off the wrist. Knock. And we're doing this 5 times.
3 times. So we can see that it's a 100-meter pipette, 100 microliter pipette, P100 range that you can take up from 20 to 100 microliters, and it's already set at 100 here. Next step, okay, adding 100 microliters of conjugate. Each well, each well, then we incubate it for 25 minutes.
Alright. So 100 microliters of our conjugate. We'll do it well again. Remember now the patient sample has already been inside, so we have to ensure that we do not contaminate the wells by cross-contamination. When we go from one well to the next. Yes, straw-colored one is our conjugate. After adding our conjugate to each well, we will cover the plate again and we head off to incubate. We do our incubation by setting our stopwatch for another 25 minutes, plus or minus 5 minutes. Okay, once incubation time has gone, wash again. Alright, so now it's time for the substrate. And how much of the substrate will we be adding, Doc?
100 microliters.
Alright.
So the pipette is already set.
And again, making sure not to touch the edges of our well. So we can use the same tip to transfer our substrate to all the wells. And we're going to incubate again for another, let's check our
Incubating for 10 to 15 minutes.
All right, so a shorter incubation period now with our substrate. After our incubation period for 10 minutes with our substrate, we can see that there has been a color change in our wells. Note, position A1, which was our blank, is still clear, and position B1, which was our negative control, is also clear. All our other tubes, which include our calibrators and our positive control, and each patient sample has changed to a lovely blue color. We're adding our stock solution. Change. The wells that were clear are still clear, and we're going to read it now.